Query processing and query optimization. Query processing is a process for the purpose of transforming a high-level query language into a correct and efficient execution plan expressed in low-level language. What is query processing? It is a three-step process that transforms a high-level query SQL into an equivalent and more efficient low-level query of relational algebra. First step of query processing is query. Query is a statement written by the user in high language using PL and SQL. Step 2 is parser and translator. Parser check the syntax and verify the relation. Parser check and perform the following operation. Syntax check, conclude SQL syntactical validity. Example, select star from employee. Here error of wrong spelling of form is given by this check. Semantic check, determine whether the statement is meaningful or not. Example, query contain a table name which does not exist is checked by this check. Careful check. Every query process a hash code during its execution. So this check determines existence of written hash code in share pool. If code exists in share pool, then database will not take additional steps for optimization and execution. Translator. Translator translates the query into an equivalent relational algebra. Here is the example. Display the name of the customer. The SQL query is select name from customer and relevant and equivalent relational algebra is by name customer. So it is the equivalence of this SQL statement select name from customer. So the step 3 is it is the query converted into algebraic form from PL/SQL by translator. Here is another example. Select ename from emp, comma ASC, where emp.eno equal to asc.eno and dur greater than 37. The equivalent relational algebra are number one is phi ename within bracket sigma du to greater than 37 and emp.eno equal to asc.eno, emp partition product asc and array2 is phi ename within bracket emp join eno within bracket sigma dur greater than 37 asc. So in this example, SQL has two equivalent array or relational algebra. Optimizer. The next option is optimizer. It will be select the query which has low cost. It selects the query in different criteria. Example, there is a two array Optimizer will select expression 2 as it avoids the expensive and large intermediate Cartesian product and therefore typically is better. So optimizer select the query which is low cost. Comparison of relational queries. Uh, there is two relational algebra query. One is uh, if we comparison of two relational query, EMP Cartesian dot ASJ, it goes to EMP dot ENO equal to ASJ dot ENO. It is stored a temp variable. Then sigma DUR greater than 37 and temp variable. Then display the email. Another query is ENO within bracket sigma DUR greater than 37 ASJ. EMP join ENO. Then phi email. So it displays the employee name. Next process is statistical data. Its statistical data is a database used for statistical analysis purpose. It helps the optimizer to choose the correct query. It is used OLAP, online analytical processing, instead of OLTP, online transaction processing system. Statistical data use the optimizer system to choose correct query which is low cost and efficient. Equivalent equivalent plan, evaluation plan. Relational algebra annotated with instruction on how to evaluate it is called a evaluation primitive. Sequence of primitive operations that can be used to evaluate a query is a query evaluation plan. So optimizer generate different evaluation plan. Evaluation and data. The evaluation engine takes the evaluation plan as condition and apply it on the data. The information on which the query has to be performed is called data. Output. After the evaluation of plan on data, process information is stored in output. So it is a last step of query processing. Diagram of query processing. First step is query. Second step is parser and translator. Then the query is translated into relational algebra form. Then optimizer choose the correct and low cost query using the statistical data and generate different evaluation plan. Evaluation engine using this evaluation plan and input as a different data generate the desired output. So it is the total process of query processing. Measure of query cost. The cost of query evaluation can be measured in terms of different resources, including fixed access, CPU time to execute a query in a distributed or parallel database system, the cost of communication. Materialization. In materialization approach, output of every single operation is saved in temporary relation for the subsequent use. It starts from the lowest level operation in the expression. Here is the example of array. I customer within bracket sigma balance less than 2500 accounts join customer. Here is an example of a query tree. Uh, Customer and account sigma balance less than 2500 customer join account at last the name of the customer is displayed. Pipelining. In pipelining approach, output of every single operation is not necessary to stay in temporary relation for the subsequent use. In this operation take place simultaneously or in background. It starts from the lowest level operation in the expression. Example is uh, by customer within bracket sigma balance less than 2500 account join customer. The expression start from the lowest level. So account within account check balance less than 2500, then join account table with customer table with the condition balance less than 2500 by customers. So the desired customer name is displayed. So it is a pipelining approach. Query optimization. It is the process of selecting the most efficient query evaluation plan from among the many strategies usually possible for processing a given query, especially if the query is complex. Here is the example of query optimization. Here is two examples of relational algebra by customer within bracket sigma branch underscore city is a book link within bracket branch join account join deposit, and another array is by customer within bracket sigma branch city equal to booking within bracket branch join account join depositor. So here is the two query tree. So thanks for watching.